All right, AB kids, we are working our way through Unit 7, and today we're looking at Section 7.6, which is called Separation of Variables with General Solutions. The next section, 7.7, is going to ask us to find particular solutions. In other words, they give us extra information so we can figure out what C actually is, and we've done that before. So, it kind of is a reminder or an idea that goes back to implicit differentiation. So I'm looking at this guy here. Remember, to be implicit, what does it mean to be implicit versus explicit? And we say that y or x, whatever, the variable isn't solved for. So an example is the equation like this for a circle. This is the circle equation with a radius of 3, square root of 9, and a center at 0, 0. So that's kind of what you're looking at, circle formula. If I were to take the derivative of this, remember how that works? It's 2x plus 2y, but you took the derivative of a y, so y prime, equals the derivative of 9 is 0. If I take and solve that for y prime, then I'm going to have a 2y times y prime equals a negative 2x, comes to the other side, divide by 2y, y prime equals negative 2x over 2y. 2's cancel, and I get negative x over y. That's what the derivative would look like. Now, this might be helpful to you if you can remember this. When you go to match slope fields, I was just talking to one student today, and she was trying to match slope fields and was having a hard time with it when you've got that matching going on. If you see this fraction, x over y, it's more than likely a circle of some sort. So keep that in mind as you're doing the slope field matches. All right, so here's the situation with the separation of variables. It's like implicit differentiation, but backwards. Separation of variables is implicit differentiation, but it's backwards. Well, we can do that. So here's the story, what you want to do. Separation of variables is exactly what it says. You want to separate the variables. You want to get the x's on one side and the y's on the other. We usually let the y's go to the left and the x's go to the right. So it's almost like this is like a proportion, as if it were an algebra equation. dy over dx equals x squared over y. Find the general solution. So I want the y's to be on the left and the x's to be on the right. And the way that I do that is, in this case, I cross multiply. So if I cross multiply, it's going to be a y dy equals an x squared dx. Right? I just cross multiplied and got that. Now once you have it separated, then what you're going to do is integrate. So I've got it separated, now I'm ready to take the integral of each side. Well, the integral of a y is a y squared over 2. The dy goes away, you took the integral. And the integral of an x squared is x cubed over, x cubed over 3. But then technically this side needs a plus c, and this side needs a plus c, but you don't need 2 plus c's, you only need 1 constant. So we usually put that on the side with the x's. Now the video that they did, they actually showed you, they left the c on the one side and the c on the other side and then combined them together, but he used like a c1 and a c2. Ultimately you get to this place. You just want a constant of some sort that's being added to this equation. So we normally put it on the side with the x's, and that's the story with that. So now, I want to get, at this point, I want to know what y is. So I've got to do some algebra shenanigans to get to solve for y. The first thing I don't like is this divided by 2. Well, to get rid of a divided by 2, I'm going to multiply by 2. So here's where I'm at next. Y squared equals 2 times x cubed over 3 plus c, right? I just moved over and multiplied. Well, let's take that a step further before, if I want to get y, I'm going to square root, right? So I want to, wait a minute. I'm going to simplify this side before I square root. Y squared equals, this would be 2x cubed over 3, 2/3 x cubed, plus technically 2 times c. Well, 2 times some constant is still a constant. So the 2 actually kind of disappeared. So maybe I'll put it in little red parentheses. It really represents 2c, but it doesn't really matter. It's still a constant of some sort. And again, the reason why I don't really care so much as to what this constant is because when I take its derivative, the derivative is 0. Whether that constant is 14 or whether it's 28, it's still a derivative of 0. It doesn't really make much matter to my function value there. So now I'm ready to take the square root. Y equals plus or minus the square root of this crazy mess. 2x cubed over 3 plus c. And that's it. You just solved for the general solution. So if I were to take the derivative of this, I get that when I solve it out. All right, so next one. If I take, this is the derivative, dy over dx, and I want to get the x's on one side and the y's on the other. So sine of x stays where it is. The dx gets multiplied over here. This one's not a cross multiply. You don't have a fraction. So this one you're going to have, let's do the x side. If I multiply this side, I'll have the sine of x dx. To get this y to the left, I have to divide by it. So that's going to be dy over y squared. Right? So this stayed where it was because it's already on the right. I want this to come to the right, so I'm going to multiply. This one has to come to the left, and I'm going to divide. Here's where I'm at. So if I look at this place, this I'm going to set it up so I can take the integral. It's not quite in a good form right now for me to take an integral, so let me think about how I can set it up so that would be a little bit better. So let's see. I could call this y to the negative 2 dy, and then this side's fine, sine of x dx. Y's are on the left, x's are on the right. Integrate. I add a power on, divide by the power. That's going to be a negative 1 over y equals, and if I integrate a sine, I get negative cosine. Plus c goes on the right with the x. And then you've got to solve for y. So you're going to kind of finagle this thing a little bit to get it so that it's y equals. The first thing I don't like is the negative, so let's negative it out over here. I have 1 over y equals, if I multiply by a negative 1, divide by a negative 1, however you want to do it, you get a cosine of x. I guess technically this would be minus c, but again, it doesn't matter because when I take the derivative, it's 0, so we usually leave it just as a plus c. Now here's something kind of interesting with fractions and proportions. Could I say, would this be mathematically correct for me to say that this is over 1? And you say, yeah, that's good. Now, can I say this? Y equals 1 over the cosine of x plus c. Would that be a valid math move? Now think about that for a minute. What did I do? And so there's rules for proportions. Proportions are when you have a fraction on the left and a fraction on the right, single fractions. And there's some rules that you can do. You can do like the numerator over the numerator, denominator equals the denominator over the denominator. There's like all sorts of different ways you can manipulate this. But all I did was a flippy-do. If I flippy-do this guy and flippy-do that guy, they are proportionally correct. They're the same values. So this actually is a really valid math move, and it comes in handy when you're trying to do these particular separation of variable problems. So don't forget all those crazy rules for proportions with this. All right, ready for number 3. X is on the right, y is on the left. That means I would have to divide by y. That's going to give me dy over y. To get the dx to the right, I'm going to x times dx, multiply both sides by dx. And I might be going kind of fast on that, but if you think about it, it's just a matter of combining those terms. If you're multiplying by it, you need to move it over, you're going to divide. And if you're dividing by it, you're going to multiply. So again, you're setting it up so you can integrate 1 over y dy equals x dx. Put it in a pretty form so you can make your life easy when you go to integrate. If I integrate this side and integrate this side, ooh, do you remember 1 over y? What does that become? Hopefully you remember. Ln of y. 1 over anything, when I integrate it, is going to be 1 over y for this case. We'll see some other cases that come into play and extra things you got to do, but equals. The integral of x is x squared over 2, and I need my plus c. Now this one adds a little bit of a dilemma because look at where my y is, and I need to solve for y. So you've got to pull out from your toolbox your rules for exponents and logarithms. Oh no, you say. We don't like exponents and logarithms. Well, this has a lot to do with them. So here's what you need to think about. If I want to get to the y and I have a logarithmic equation, what I need to do is change it to an exponent. So let me take a different color here and take an adventure with you. What's the invisible base on an ln? It's an e. And do you, by any means, remember the loop? Here it goes. Whoop. Remember that guy? Remember the loop? The loop says that you have e to the x squared over 2 plus c equals y. Look at how easy that was to solve for y if you can remember how that rule goes. So y actually equals, I'm going to put it over here because I've got more to say about it, y actually equals e to the x squared over 2 plus c. Now normally, and this is going to come up more in the next couple sections, especially the last section of the unit, here's what they actually think of, the way that they would write this. This would be like, this is, by the way, this is a perfectly valid answer, but the one you'll see that's more popular is this. If I look at it this way, e to the x squared over 2, because I'm adding the exponents, it would be times e to the c. If I broke it apart. If I made them as two separate pieces, this one's e to the x squared over 2, this one's e to the c. They're being multiplied because the exponents are being added. So, what can you tell me about this piece of that equation? Oh, don't get too excited. E to the c is still a constant, isn't it? It's some constant times e to the x squared over 2. That's the answer that you're going to see that's more popular. Because this is a constant, it just sticks as a constant. So ce to the x squared over 2 is your final best answer for that. By the way, these are equivalent answers. The AP people tend to like this guy a little bit better. So that's your story on that. Okay, last example, and then we got a couple of problems we'll do together from the practice. This one is in no way can I split this up where the x's are on one side and the y's on the other in the form that it's currently in. So what I need to do is think for a moment and decide, is there a way that I can change the way that looks so that I can separate the variables? And so the only thing I think of is factoring. If I look at this, I can see 2x could come out. Let's see what that does for me. If I factor out a 2x, that gives me a y plus. If I factor out a 2x from here, I get 2. Oh, I think I can do it then. So the y piece comes to the left by division, dy over y plus 2. And the x piece stays where it is, 2x, and I times the dx to the other side. So I'm setting it up to be able to integrate. This is 1 over y plus 2 dy equals 2x dx. And now I can integrate both pieces. Integrate, integrate. Well, this guy actually is again an ln, right? 1 over something. So the ln of y plus 2. Usually when you take those ln's, you always keep them in absolute values because you can't take the ln or a log of a negative number. So we just automatically, when you take an ln, you've got an absolute value with it. This one would be 2x squared over 2 plus c, where these 2's cancel. So my next best piece is the ln of y plus 2 equals x squared plus c. Well, the same thing happens as in the last problem, because I want the y by itself and the y is tangled up with this logarithm. So what I need to do is remember my base of e, remember my loop, got all my colors going on here, remember how the loop goes. Here's what it's going to look like. E to the x squared plus c equals y plus 2. All right, let's change this side to what it should look like in this better form. That would be c e to the x squared equals y plus 2, right? Because it'd be e to the x squared, e to the c, that's still a c. So it's c e to the x squared. How do you solve for y now? That's pretty simple in the scheme of things. Y would equal c e to the x squared minus 2. You take the 2 out of there, and that gives you your equation. And there you go. So they are the examples for section 7.6. Let's flip over. We're going to do 2 practice problems. There's only 8. There's also no test prep for this particular section. First one I picked is number 3. Here's number 3. Get the y's on the left, the x's on the right. That means I'm dividing by y squared, dy over y squared equals e to the x times dx. Multiply by the dx. You're dividing by y squared, multiplying by dx separates them up. Set it up for your integral. This would actually be 1 over y squared. Are you okay if I just call it y to the negative 2? Cool. Integrate gives me negative 1 over y equals e to the x. Remember, e to the x is its own derivative and integral. So e to the x plus c. First thing I do not like is the negative. Let's get rid of that. Multiply by a negative. By the way, this would make this a negative c. Does it matter? Absolutely not. We normally keep it as plus or minus, whatever that constant is. Oh no, that's not what I want. My y is in the bottom. So play the reciprocal trick. Put this over 1, flip them. Y equals negative e to the x plus c. But it's, wait a minute, I didn't give myself enough room. If I flip it, then the 1 is on top, and the negative e to the x plus c is on the bottom. That's your final answer. That's it. I don't find these very complicated. It might get a little bit messy sometimes in the beginning, trying to get the x's on the left, the y's on the left and the x's on the right. Some of your algebraic manipulations with that, but ultimately these are relatively nice. All right, here's the last one I'm going to do. Number 8. This one I can cross multiply. See how if I cross multiply, I have a fraction, which makes this different than the others. If I have a fraction, I can just cross multiply these. It's going to give me the y's on the left and the x's on the right. So here we go. E to the 2y dy equals 2x dx. Sure, I can integrate that. Integrate. Now this time it's a little bit, don't forget this. I think kids tend to forget. E is its own integral. However, you've got to divide by, remember, because you're integrating, you're dividing, by whatever the derivative of that power is. So you've got divided by 2. Equals, if I take this guy, add a power on, divide by the power plus c. And then it's a matter of me digging to get y by itself. So let's see a couple things we can do. First, I can cancel these 2's, right? This is really a 1/2 e to the 2y equals x squared plus c. The next thing is I'm trying to dig towards this y is getting rid of this 1/2. So I'm going to multiply both sides by 2. That's going to give me e to the 2y equals 2x squared plus 2c. I don't care, it's 2c, it's just a c. All right, reason why I picked this one. I'm digging for the y. The y is part of an exponent, And the only way I can bring that down is using logarithms, going the other way. And so if I logarithm this, the powers are allowed to come down in front if I take the natural log or the logarithm of both sides. Do you see what I did? So the power comes down in front, ln of e, ln of this side. Algebra balance, got to take the logarithm of both sides. Well, the ln of e is 1. And most people don't even show that part, but I always show it just so you don't get lost on. It looks like it would be unbalanced, like that you didn't do the same thing to both sides of the equal sign, so I normally keep it there, but remember it's 1. Now, look at what I got. This is kind of nice. 2y equals this crazy ln on the other side, right? I want y by itself, and you say, all right, no big deal, divide by 2. And I say, okay, let me do that. Could I also have put a 1/2 in front? This is kind of, I'm just going to expand on that. This is a perfectly valid answer right here. Let me go into box number 7 and show you some alternate forms you could see this in as a multiple choice question. So I could see it as this, y equals, yes, you can see me, 1/2 the ln of 2x squared plus c. I could see it written that way. Okay, that's cool. Another way I could see it written that you might not think about, but if you put your thinking cap on, maybe you'll get it. The number in front is the power. And so really if I'm to the 1/2 power, I'm like a square root. So here's another alternate form you could see this thing as, and that would be the square root. Sometimes you'll see it this way. And they write it funny. The square root of 2x squared plus c. In an absolute value, because you can't take the ln of a negative number. So again, alternate forms. I probably would go for this first version that we did or the second version that we did. But just remember, if you're trying to match it to a multiple choice question, there you go. All right, that takes care of section 7.6. All right, we're on to section 7.7 next. And that's going to be when they give us more information so that we can figure out what C actually is. So that's going to be our next one. Shoot me an email if you got any questions.